Welcome to day 13 of our Python programming course. Today we will be diving into exception handling in Python. We will explore how exceptions work, how to manage them efficiently, and how to raise your own custom exceptions for better control over your programs. Let's start by understanding what exceptions are. Exceptions are errors that disrupt the normal flow of your program. They occur during the execution of your program, often causing it to crash if not handled properly. So, why should we handle exceptions? The main reason is to prevent your program from abruptly stopping. Instead, we can provide meaningful error messages to the user, improving the overall experience. In Python, we use the try, except, finally structure to handle exceptions. Here's how it works. The try block contains the code that might raise an error. The except block is where we catch and handle the exception if one occurs. The finally block runs no matter what, whether an exception occurred or not, allowing us to clean up resources or execute important final steps. Let's look at an example. In this code, we ask the user to enter two numbers and perform a division. If the user enters a non-numeric value, a value error will be raised. If the user tries to divide by 0, a zero division error will occur. Regardless of the error, the finally block will always print execution completed. This ensures that the program does not crash unexpectedly. Sometimes you might want to explicitly raise an exception in your program. You can do this by using the raise keyword followed by the exception type and an optional error message. In this example, we define a function to check if someone's age is under 18. If it is, we raise a value error signaling that the age must be 18 or older. Here we call the check age function with an age of 16. Since 16 is less than 18, a value error is raised. We catch this exception in the except block and print a custom error message. Error: age must be 18 or older. Now let's talk about custom exceptions. In Python, you can create your own exception by subclassing the built-in exception class. In this example, we define a custom exception called negative number error, which is raised if a number less than 0 is processed. This gives us more control over how specific errors are handled. In this example, we attempt to process the number -5. Since negative numbers are not allowed, we raise the negative number error exception. This exception is caught in the except block, which where we print the error message: error, negative numbers are not allowed. Sometimes you need to catch multiple types of exceptions in one block. You can do this by specifying a tuple of exception types in the except clause. In this example, we handle both value error and zero division error in one block. If either exception occurs, we print the corresponding error message. Exceptions in Python follow a hierarchical structure. The base class for all exceptions is base exception, followed by exception and various specific exceptions like value error, division zero error, and file not found error. Understanding this hierarchy helps you know which exceptions can be caught and how to handle them appropriately. When an exception occurs, Python provides a traceback message, which is a detailed error report that helps you identify where the error happened in your code. Here we see that when we try to divide 10 by 0, Python raises a zero division error and provides a traceback to help you pinpoint the exact location of the error. Now it's your turn. For this exercise, write a program that prompts the user to enter a number. Your program should handle invalid input such as value error when the input is not a number. It, it should also handle zero division error when the user tries to divide by 0. Additionally, raise a custom exception if the input is 0, indicating that 0 is not allowed. To wrap up, remember that exception handling is crucial in ensuring your program runs smoothly even when errors occur. By using try, except, and finally blocks, we can catch and handle errors efficiently. Raising custom exceptions gives you even more control over how errors are managed. Lastly, always use Python's helpful tracebacks for debugging. Happy coding!